In this 45 minutes we're together. It's going to go pretty quickly probably. We have a ton of things that we want to show you, and then we have a live demo that we want you to interact with. If all goes well, the network stays up, and the music stays off, we're going to have a good time.
But if the music comes on, everybody just get up and start,
Start dancing.
You probably didn't need to see that, did you?
And to introduce Dan here, Dan Rades is specifically going to help me do the presentation overall. I wanted to make sure that we had some additional OpenStack expertise. So Dan is at the infrastructure level of the stack. He's lower in the stack, if you will, down here more at the OpenStack level. And I live more at the JBoss level. And then between the two of us, we'll cover some OpenShift, which is kind of the glue, if you will, between those two worlds. So this diagram is an overly simplified diagram to kind of illustrate the point. I think most people in our business, right, understand that there's a piece of hardware someplace. There's a server, a pizza box, if you will, a laptop in this case. And when Dan and I did this presentation a few months ago, we actually had a series of laptops that we put up on the stage with us, and we built a little cloud out of a series of laptops. And that's literally what we did. It was a set of laptops and a switch, and we had a network drop coming in for the internet, and that was it. That was our focus, to build a cloud out of that. So on the piece of hardware, you can drop a couple virtual machines. Most people are comfortable with virtualization these days. You drop a couple virtual machines in there. Some of the rules of thumb you see is, there's somewhere around, 4 to 10 virtual machines on a piece of hardware in many cases. Maybe some people say you can get more. Some people say less. I've heard all sorts of numbers. In the case of our little laptops, we put in 2 because they're laptops. Now, what's interesting is within each of these virtual machines, you drop in containers now. So you have another layer of density that you can add. So instead of having a whole big, fat, heavy virtual machine, you can have these little containers in the virtual machine. And what we found with like OpenShift Online, OpenShift.com, you can have hundreds of containers in a virtual machine. In our case, being we're working on little laptops, we put 2 containers in the virtual machine and on top of 1 piece of hardware. As an example. So you'd had 4 containers on the actual hardware, right? So 2 VMs, 2 containers each. But that container is basically what you think of as your operating system as a developer. It's your Java virtual machine. That's where that lives. So your JVM, if you're heap space and if you're a Java programmer, that's where that thing lives. If you're a PHP programmer or Python programmer, Node.js programmer, that's where your runtime is, right? That's the component that you need to then put your apps on top. So if you're a Java person, that's where your WAR file goes. If you're a PHP person, that's where your PHP files go. If you're a Node.js person, that's where you drop all your Node.js, JavaScript files, things like that. And so the middleware layer is a layer I'm going to spend some time showing you guys also. So we have obviously application server middleware for people who want to build a Java-based stack. We have integration middleware for people who want to connect a bunch of different things, and we'll actually show you an example of where we connected several different things to show you the demo application. BPMS software, business rule software, all those things are then there for you to then build on the very top of, right? So in other words, your WAR file in the Java land can make an invocation of a web service running in one process, execute the business rules in a business rule engine running in another process potentially, and then display something to the user if that's what you want to do, right? Up on a web-based screen as an example. So your code lives at the top of that stack. Again, this is an oversimplified way to put all this, but you're going to kind of see all this in action as we get through this. So at this moment, I want to turn this over to Dan, who's going to drop down into the OpenStack piece. He's really our OpenStack expert, and he's going to show you some pretty cool stuff around OpenStack and how you can quickly and easily get started with OpenStack should you want to put your hands on it.
So how many people know how to spell OpenStack? Let's start there. Come on, everybody, put your hands up. Don't fall asleep on me yet. So how many folks in here have used OpenStack and have a familiarity, a little bit of what it does and how it functions? Okay, and keep your hand up if you've done an installation or you've operated OpenStack. Okay, so hopefully this will be relevant for most of you. I think most of the folks in here may not be quite familiar with it, so I'm going to go through a quick overview of a couple of things that you can do kind of conceptually in building a cloud, right? So we've kind of got 5 levels here, starting at the physical hardware and moving up into your code. So we're looking at, in OpenStack, taking that physical hardware and turning it into virtualization and how to manage that layer there. What I'm going to show you today is RDO, and to explain RDO, it's simply OpenStack from the community. It's upstream code pulled directly from the Git repos, and then Red Hat packages it in RPMs and gives you these RPMs. So it's our community distribution of OpenStack. So if you want an easy place to go and get OpenStack, if you're familiar with RPM, this is where you want to go, OpenStack Red Hat COM. There's an installer that we include that's kind of a one-off demo, get started sort of thing called PackStack. And on the OpenStack Red Hat COM site, there's instructions on how to use that. But if you want to give it a whirl to install OpenStack, you can do an all-in-one installation where it puts it all on one server. PackStack has the ability to do multiple servers if you want to do a multi-node installation. But this is where I recommend getting started. And what you're going to see that I'm going to demo right here is exactly what you would get if you went out and installed RDO and started using it today. Another place that you can go to try out OpenStack is TriStack. And all TriStack is RDO running on a cluster of servers for you to use free of cost. There's lots of stickers here, so if you want stickers, RDO TriStack stickers, Burr will get them to you there. So right now it's integrated with Facebook. We're hopefully going to integrate it with the OpenStack Foundation for authentication in the future. The idea is we want to give you a way to log into a running OpenStack cluster and be able to do the basic end user operations in there so that if you're not familiar with what OpenStack can do, you can give it a try without the installation side of it. OpenStack is kind of well known for being a bear to get installed the first time. PackStack and RDO certainly helps that happen, but to get into a larger scale installation, there's a lot to understand and learn about what's happening under the covers. TriStack's a way to try it out with kind of skipping some of that trouble. This is the OpenStack Red Hat COM site. So there's a quick start here and lots of directions there. And then this is what TriStack looks like. You got to start by joining our Facebook group with this link here. And it'll take usually 24 to 48 hours for your account to be approved. And then go down to this login page. And when you click on that login page, it'll give you a page that looks like this. And so this is the login to the OpenStack dashboard, to the web interface to OpenStack. A quick qualification about this. What you're going to see today is actually the test cluster that I have internal to Red Hat that is me testing the upgrade of TriStack. So next week, unfortunately, TriStack will be mostly unavailable. Horrible timing on my part, I understand, but I'm trying to have it ready for the OpenStack Summit the beginning of November. We want to have it upgraded to the latest GA, which is the J release in OpenStack. So next week, you're going to get shiny new bits on TriStack. So go ahead and apply to the Facebook page and keep in touch, and hopefully we'll get you up and running on Juno very quickly. So once it comes back up, you're going to get a login that looks like this. So I'm going to log in just as the administrator here. Should have had an easier password to type. It's too long. When you log in, you're going to get a dashboard here that shows you for your user what you can do with OpenStack. A main thing to note here is the two panels. The project panel is one that you will get as an end user. So this will be where you kind of you create all the virtual resources in OpenStack that you're going to use. The admin and identity panels at the bottom are admin specific. So if you end up installing your own OpenStack cluster and start to use it, you'll have access to those. And those are more system level actions and operations that can happen. So I'm going to focus on kind of the end user project side of this. So OpenStack is a way to manage virtualization, right? Let's not kid ourselves. Cloud is just a fancy way to say virtualization, which has been around for years, right? And so for us, what we're able to do in OpenStack, though, is to have these pre-baked images that instead of you launching a virtual machine and then having to install an operating system, you give it a preloaded disk image that you can build either to be very vanilla or very customized. You can do as many as you want. So one of the things it can manage is images. So I've put in here a Fedora 20 image for us to use. So for us to launch an instance, we're going to need an image that you're able to launch from, and then we need a network to attach to. The dashboard has kind of this neat visualization thing that'll show us our network as we build it. In TriStack, you're going to be provided an external network. So you can see here that there's that blue line is the external network, so that's your connectivity to the outside world. So there'll be a subnet of IP addresses that you can allocate IP addresses that will get connected into your instances when they run. The way it functions, though, is that there's per-tenant networks, and what that means is that each individual instance can run on a private network inside of this cloud. So within your project, you've got to go in and create a network for it to run on. So I'm going to select networks, I'm going to create a network, and I'm going to call it internal to be really creative today. That was funny. Come on. Haha, funny, funny. Okay. So you're still with me, right? I'm just going to give it a 192, 168, 122. And there's a checkbox that enables DHCP, and I'll give it Google's multiple 8s DNS record. So now we have an internal network, right? So this is where the instance would connect to. So look back at the topology, and it should show us the external network and the internal network, but they have no route to one another, right? So if an instance came up on that internal network, it wouldn't be able to really go anywhere, right? Because it's on an isolated, this is essentially the same as if you brought up an instance and plugged it into a switch that was plugged into nothing, you know, you've plugged it into a switch, and that's about it, right? So you create a router to go with it, and I left my one from earlier while I was testing in there. There's two actions that we take. One, I'm going to click this Set Gateway button, and I'm going to select the external network, so that creates the connection out to that external network that's provided to you. I drill down into the router now, and I add an interface, and select the internal network. So now we can go back visually, and by setting the gateway and adding the interface, we now have a route between the internal and the external network. So an instance is going to come up on the internal network, it's going to get an IP address from it, and then we're going to give it what's called a floating IP, which is an IP within that external subnet, and then OpenStack will connect the routing between those so that the traffic gets forwarded from that public address into the private address on your instance, and you can use it. So now that we have an image that you want to launch from and a network to connect it to, now we can actually launch that instance. So we'll go up to Compute, select Instances, and launch an instance. There's all kinds of options and stuff to talk through here, and I don't have time to go through all of them, so I'm going to try and hit a couple of high points. I'm going to name it Demo, right? Yay for creativity. The flavors, I've selected small here, and you'll see as I change the flavors, the numbers over on that right-hand table change. All I'm doing there is allocating how many vCPUs and how much RAM and disk space and stuff will be allocated to that virtual machine when it's launched. There's lots of different boot sources that you can come from. I'm just going to select image, which is that Fedora image that I selected or uploaded before. So I'm selecting my Fedora 20 image. In access and security, what you end up doing is, this is kind of like Amazon, right? An SSH key pair is put onto the instance for you when it starts running so that you end up authenticating to it passwordless. So in access and security, you can manage a set of key pairs. I've already put my pub key. All I did was copy and paste my pub key into the form to create one. So you could say, click this plus button and say key pair name new, copy and paste your pub key there, and then you'd have a public key that could be dropped onto those instances when they start running. And then let's take a quick look at networking. It's auto-selected internal for me because I only have one network. You could have other networks, so if there was more than one and it didn't know just to select the only one that you have, you'd go in and select a network here. Obviously here I just have internal. Another thing to notice is on that access and security tab, I've got security groups. This is sort of a firewall sort of thing within OpenStack, and we'll get to that in just a minute after we launch the instance. Post-creation and advanced options are, we'll skip those for right now because they're a discussion we can have later. Let's make sure we get through all this. So at this point, he's going to take that disk image that is in Glance, the image component, he's going to copy it out to the compute node, and he's going to spawn that virtual machine, and this instance should come up and be ready for us to start using. I mentioned earlier that you have the internal address that's allocated. So here the 192.168.122 address has been allocated to the instance. But to get to it publicly, you're going to want a public address. And so over here, there's an Associate Floating IP button. I've already got an IP address allocated to my project. It's important to differentiate the difference between allocating and associating a floating IP. there's a pool of floating IPs out there in that external subnet that what you have to do is first take one of those IPs and allocate it to your project so that you own it. You can attach it and no one else can then use it. So I've already done that because there's one listed here, but if I click this plus button, I could go out and say, from the external network, give me a new IP address. And so if I allocate, this will just give me a second IP address. Now I have 2 listed in that. So the 10.1, 254, 131, and 134 are the 2 that's in there. Those 2 IP addresses have been allocated to the project, but they're not yet associated to an instance. So if I select one of these IP addresses and say associate, it will now associate that floating IP with my instance so that if I try and connect to that IP address, the traffic will be properly routed into the instance. So at this point, with this public IP, I should be able to go out to, yeah. We're not bumping yet. Hold tight, everybody. So we talked about security groups earlier. So here, if I try and ping this floating IP, I don't get any response because there's essentially a firewall rule that's not been created to allow the traffic to go through. So if I go back into, all right, now everybody get up. Here we go. I totally got thrown off by that. What was I talking about? Security groups, thank you, yeah. So I have this access and security tab over here on the side. If I select that, there we go. Here's my default security group that was checkboxed when we launched that instance. So I'm going to manage rules. And these rules here basically say that traffic can get out and traffic can get between instances within the network that they're on. But there's nothing that says allow traffic in. So if I add a rule to it, I'm going to say all ICMP is what I've selected there. And the second one says the direction is ingress. So that's saying anything incoming that's ICMP, go ahead and allow it. And with any luck, my test cluster that I'm working on upgrading TriStack in will work, and we'll get a ping. Oh, no. No good. Everybody say, oh. Thank you for your participation. So moving forward, there's still a few bugs to work out before my upgrade next week in TriStack. I hope to have them all worked out. I'm going to, for example's sake, you'd go in then and say SSH is down here at the bottom and add that rule. So now with ICMP there and SSH there, I should be able to ping the instance and SSH to it. Why I can't is a whole nother debugging session that we don't have scheduled, so we can discuss that later. So once this instance comes up and is running and you could ping it and you could SSH to it, then you want to start using it. So you could SSH into it, you could start to install software that's on it, right? We created a route out to the external network so you can get to out to Google and install packages and do whatever you need to do, but you might need extra storage. So there's volumes here. So Cinder is the volume component. You can go in and create a volume and say, hey, I need a gig of space, volume name, so I'll give it a name. And so down at the bottom, size is a gig. You could up that if you wanted, create volume. So it's going to allocate that volume, and then you could associate it with one of your running instances. Apparently, I don't have Cinder set up either properly. And the same thing with object storage, right? I know I don't have object storage working, but there's a tab down here, object storage. So the same that Amazon has S3 for their simple object storage, OpenStack has object storage. So Swift, you could then put simple objects into Swift and store them, and then retrieve them with your instances, et cetera, et cetera. The last one down here is orchestration. So Heat is the orchestrator. And actually, that's kind of where we're going in this demo, right? That if Heat was configured here in this lab that we're working towards Juno on TriStack in, you could create a template. And so what Heat does is takes this template and says, okay, instead of just launching one instance at a time or 2 or 3 of the same exact instance, maybe you want to configure them differently. Maybe you need a web server. Maybe you need a database. Maybe you need a proxy server. Maybe you need an OpenShift broker and an OpenShift node so that you can run OpenShift on top of OpenStack. So you'd have your physical hardware, you'd have your OpenStack infrastructure, you'd have your PaaS, your platform would be OpenShift, and then we get further up into the middleware, which Burr's going to talk about in a minute. So Heat is a way that you could do that. And if you go out to GitHub, there's OpenStack Heat templates. I should have had this up ahead of time. There we go. So this is a GitHub repository of a bunch of example Heat templates that you can go out and use. And the OpenShift origin guys have put templates in there. So here's a CentOS 6.5 OpenShift right here. It's called OpenShift B1N1, or 1B, 1N. And so what that means is one broker, one node. So when you create an OpenShift cluster, there's brokers and there's nodes, and you interact with those to launch and create your applications. So this template could be passed into Heat, and Heat could then launch multiple different instances that do different things, and Heat will orchestrate all the information between those instances, so you end up with a running OpenShift cluster. So on the note of us using Heat to have OpenShift running, let's have Burr move on with getting into the PaaS layer and beyond with middleware.
All right. So you need to switch the VGA cable. Did you wire that in pretty hard?
I don't know. There we go. It didn't want to let go.
There we go.
It loves Lenovo.
Marriage made in heaven. Fantastic. All right, we got a few more minutes left. We'll keep rocking along here. Let's see what the screen resolution comes back as. I had reason to have the phone there. We're going to see something happen on the phone if all goes well. So let's keep moving along here. He mentioned Heat, and specifically with Heat, you can set up, using Heat templates, you can, of course, configure whatever you need across the backbone of infrastructure you just created. So you got your CPUs, you got your networking, you got your storage, and now we put something on top of that. In the actual demonstration we did previous to this one, we didn't bring all the hardware with us today. We used Heat to then throw OpenShift down on top of that infrastructure. So with OpenShift, it's a platform as a service. So think infrastructure as a service, platform as a service, and this is for developers to self-serve. A developer can then say, hey, I need a couple app servers stood up. I need a couple databases stood up. I need a couple message brokers stood up. And they could do that through this console here. And this is just an example of OpenShift Online, just to kind of show you how it works. And so I can easily look at the menu of things I, as a developer, can launch. So the administrator, the OpenShift administrator, determines what that menu looks like. And I can say, oh, I want a Drupal engine. I want a WordPress engine. There's organizations out there who allow all their employees to start their own WordPress, their own blog, as an example. And that's a big win for them, because that way they can manage it in a central way, a central location. They know exactly all their underlying hardware and infrastructure below all those different blogs that their employees have all launched. But I'm going to actually pick something a little more interesting. I'm going to run the JBoss Business Process Management Suite. This is actually a fairly big item. I'm going to launch it here in a specific domain, one called Burr. I'm going to say I want a medium gear. And again, the OpenShift administrator will determine what the quota is for me. How many gears can I start? How many containers can I start? And what size can they be? I'll say I want a medium. And no scaling, run in the east, hit create, and let that thing go. All right, so that'll be running for a few moments here. We won't wait on it, and what I'll do is I'll switch to my local host version of the same thing. So one of the things we always focus on as an open source player that we are is we firmly believe that anything you can build and run out there in a massively scalable way should also be able to run on your laptop as well. So I have the whole BPMS suite running here. This is our Drools and JBPM technology. So the business process management engine, as well as the Drools rules engine, essentially running here locally, including a dashboard I'll show you in a second. But I really want to show you this Fuse technology. So this is where it gets interesting. So I guess I should have showed you a picture. I had a picture. Let me show you the picture. We'll start at the end. All right? This is the application what I'm going to be demonstrating here. So you heard about OpenStack from Dan. So OpenShift I kind of just mentioned and how it runs. It sits on top of that infrastructure, right? Platform as a service. And then you use our Fuse technology to basically say, hey, OpenShift, go do things on my behalf. And what we're going to do is launch services across the backbone. So I'll show you the services launching here locally. All they're going to do is launch different Java virtual machine processes. But if you want to launch one of them, you can. If you want to launch 1,000 of them, you can, with the click of a button, is the idea. Go start all these things up. And so I'm going to run a Fuse service. It's an integration service. It's going to read tweets from the Twitter API in real time. It's going to go to Salesforce to look to see if there's a Twitter ID matched to a Salesforce record. Because if there is a match, then you might be a customer of mine. And if you're a customer of mine, I might care about what you say. If you say, hey, I'm really unhappy with JBoss, or I'm really unhappy with Red Hat for these different reasons, I might want a customer service person to then call you, as an example. So if, in fact, we find your record in Salesforce, we start a BPM process. We're also running on this local machine. And then we'll send you a text message in response to your tweet to say, yes, we got your information. We'll be contacting you shortly on your phone through Twilio API. And then you work the process through the standard BPM process flow. So it sounds complicated, right? It actually is fairly complicated. It's a complicated demo. And the cool thing is I've made all this thing run here on this laptop. But I've even taken this thing down to like Santiago, Chile. So think about it. People were in the audience were tweeting. That was going to California or wherever the Twitter keeps their data center, coming back to my laptop on stage, going back out to Salesforce, wherever their data center is, back to the laptop on stage, right? Then out to Twilio for the SMS message to get to their phone through their standard cellular network. And all that would happen within a few minutes. So we'll have to see how this works out. Now, in your case, none of you guys are in my Salesforce database, but you'll see this kind of work. OK? So this is the Fuse Management Console. This is actually based on an open source technology called Fabric 8 and Hot.io. So if you're into this sort of thing, it's a fabric-based technology, which means I can elastically scale services based on my demand and need. And so I'm going to come in here and say, I actually have two profiles. I'll show you that real quick. I call this Keynote Twitter Stream and Salesforce. Probably hard to read here. I can zoom in. So there's Salesforce and Stream. And I'm going to say, I want to launch one of those now. So I'm going to say Create. I'm going to start the Twitter one. And come down here and pick the right profile. This basically, we'll just go ahead and click the button and get it going. And then hit Create here. And one of the things I'll do is jump over here to the activity monitor, and you'll notice that there's 2 JVMs already started. You should see a third if all goes well. There it is, pops in. So it's now cranking up that Java virtual machine. And more importantly, it's actually provisioning all the middleware components necessary to give it its personality, right? It's not just the raw operating system, the raw container with the Java virtual machine on it. It is also now going to basically have all the Camel-based middleware. This is this Apache Camel project that it needs to do the integration layer. It's going to have all the infrastructure it needs to do any kind of HTTP connectivity it needs. So all the different jar files that make up your app, think of those being dynamically provisioned out there at the same time. So it was a raw nothing before. It was a raw virtual machine before, a raw Java virtual machine. Now it's going to have everything it needs to have my custom logic on it. If I drill down on it here, so it's already started. It starts very quickly here locally, obviously. You can see there's the logs associated with it. And I can click over here. And I'm connected to this process now. So it is another process. You can see at the very top, it's basically looking at the streaming API for Twitter. It's doing a log. It does a conversion through a little Java bean, marshals that data, and then it kicks it over to a certain message queue. OK? So let's do that real quick. I want to come over here to let's not use that user just yet. I have several Twitter IDs. OK? So demo up. This is a test from Raleigh, if I spell Raleigh correctly, and hit tweet. OK, and then switch back to my Chrome. And then you can already see it. It's already come in. See the one there? So that already went out to Twitter and back again here to this machine that fast. That's really the magic of the Twitter API, not really anything we've done. But to kind of make that point, we're going to drill down to the management console here on the message queue itself. So the message broker. And here's the queue. There it is. There's the message. You can see there it is. This is the test from Raleigh. So there's the message already in the system. So any tweet that you guys send that has the hashtag demo up or demo down would actually show up right here in my queue as well. So that is happening in real time. And again, the magic of this is simply coming over here and saying, let me go back to my main screen. I want to create a new container. You pick the appropriate profile, which is the package of your business logic and, of course, the dependencies on the underlying infrastructure, or in this case, middleware technology, and it launches it. So that'll work, like I said, 1 time or 1,000 times across the backbone of OpenShift and OpenStack. And so that was the demonstration that we've primarily been showing for the last couple months, is actually saying, OK, we can add additional hardware to give additional capacity, set up using Pixie Boot so they have the right underlying operating system on there. They get the right OpenStack on there, and then, of course, OpenShift on there. I got a couple more things to show, Dan. Watch this. Okay, so we have that container started. Now I'm going to show you the next container. We're going to start one more. We're going to actually then run our Salesforce container, all right, because I mentioned that it connects to Salesforce. And I'm going to come over here and say I want the Salesforce profile. There it is. And boom, click the button, hit create and start. And if all goes well, dun, dun. And as it start, it's still starting. You see it starting right there. You can kind of just see it, the little icon there we go. Oop, zoom out. And there's the text message on my phone. It just came in. It's kind of hard to read there, isn't it? Thank you for your tweet. Your tracking number is 9. I've run 9 tests in this so far. Okay, so let's kind of show you that. Over here, so the Salesforce thing ran. Let me drill down on it and show you the camel route for that. Again, we like to visualize the camel routes. It looks like we have 4 messages now coming through the system. Okay, but you can see it runs from the queue, unmarshals it, logs it. Then we basically run it. We basically have a to Salesforce bean, which basically kicks it out to Salesforce to see if in fact there's a record in the Salesforce. So here's my little Salesforce content over here. And then it basically comes down and says, insert it into the database, and then run the BPM process down here at the bottom. So at the very bottom, it's running the BPM process there. Okay? To look at that and drill down on it, I'm going to come over here and hit refresh. You can see there's now 16 in the system. And this is a tweet from Raleigh. So that tweet now has gone up to Salesforce. We found that record. We matched it up. We put it here in the database locally. And now I have a business process that's been woken up, and I can process this thing. So all this is middleware technology that you can use to build your own custom business process. If I want to come here and say I want to do a, let's just go to process definitions. You can see there's the customer follow-up there. And if I want to look at that in more detail, actually, let's do this. Project authoring. Business process, just to kind of give you a feel for this. Let's just do a new item, new business process. Raleigh. Helps if I spell Raleigh correctly. Okay. And if all goes well, there we go. My screen is a little bit small here, but this is how we design a business process. So you can say I want to add a new node. I want to add a component here, add another component here. You just design your business process using BPMN2. So we have a visual modeler built right into the browser. Again, this is based on the Drools open source project. So you can go download all this today and check it out. But we already have the business process already started here. That creates these tasks in my task list. OK, I don't need to save. This guy right here. Then we go to the work, and you can see there. This is a tweet from Raleigh. I, as a user, can claim that task, start working on that task. And then I can then say requires customer escalation, because that might be something, a customer service issue I need to look at, as an example. So the cool thing about what you see here is a complete working application that shows kind of advanced integration scenarios, a business process, which is also kind of an advanced scenario, but all working across that common backbone. All this will work across your OpenStack and OpenShift, and then all this sits on top. I'll show you another item just so you can see it happening here. And you can see some other people have already tweeted into the system. You can see right there, David Henry and Daniel Farrell. Kevin, are you guys around here? Right? All right, there you go. But we have a dashboard that shows you, in this case, it's a business dashboard to show me the interactions that are happening within my software. This is a live system, as you can see. And I could take those people's records, add them to Salesforce, and then you would then get the text message as well. Right? Right now, we don't have your phone number. We just have your Twitter ID. So, and to get your phone number, you got to pull that out of Salesforce.
So who wants to provide their phone number today? Obviously, we could then respond to your support request via Twitter after that, right?
Yeah, exactly. So you can see they're in the no Salesforce category over here. Those folks have been tweeting, and you can kind of see there's Kevin's tweet right there as an example, watching OpenShift on OpenStack demo. Okay. So those are the critical points. Let me make sure I double check. I showed you all the things that were critical there. I guess I can show you one more tweet just to make the point. Like here's my actual Twitter one. So again, demo up. We also do demo down. So think of demo up like a thumbs up. We like the demo. Demo down, thumbs down. Don't like the demo. But this is, of course, our OpenStack plus OpenShift And we're, all that based on with JBoss xPaaS. That's how we refer to these various middleware services that sit on top of all this platform as a service infrastructure. Is totally awesome. How about that? And tweet that in, and we come over here. You can see it's still processing back here in the background. Where's my dashboard again? Let me see. Did that one make it in? Okay. Yep. There's that one, and it should have given me a new. Yep. There's my new tracking number there on my phone. All right, because my Twitter ID is in Salesforce, and it found my phone number. Okay. And of course you get other notifications from Twitter, right? Okay. So at this point, that's a whirlwind tour of what we want to show you, but that kind of gives you a good idea for what all the different capabilities we're focused on. The key thing here is understanding that we want to be fully taking advantage of the elasticity of the cloud. So all the middleware infrastructure that you add with your custom code, like in this case, if you want to build an application that has this kind of component on it, like this Twitter component, this Twitter component or this Salesforce component like this, an integration component, you can deploy that across all the backbone that you've created with OpenStack and OpenShift. And actually, to make that point, I'll show you that my application took longer than expected. Oh well. Well, that was the BPMS that I started up there on OpenShift.com, and it failed, unfortunately. This is why you don't wait around on it and see if in a live demo scenario. But
so
here it is running locally.
What you see here is we've shown multiple different pieces of all this application running kind of in different places, but conceptually, you could layer them all together, and on your hardware, you could run OpenStack, and on top of OpenStack, you could run OpenShift, and on top of OpenShift, you could run the Fuse gear, and then you could have the JBPMS that communicates with Fuse, and so all of this here can be built one on top of the layers. We've just kind of pulled them from different places to help our demo kind of succeed, if it did, I hope.
Yeah.
But hopefully that helps to conceptualize what we're intending to kind of show that stacking of all these different layers, all these different technologies to end up accomplishing. Here we've pulled information in from Twitter and connected to Salesforce, but whatever your business process may be, all these layers can help you to achieve that.
So we have a few minutes for questions before we're going to run out of here in about 5-6 more minutes. But what kind of questions do you guys have? Wow, stunned silence. I know it's after lunch, but
Who wants a sticker? We got a big pile up here.
we do have a bunch of stickers for you guys. That way you can do trystack.org and try your own hand at OpenStack, and then OpenShift.com to try your own hand at OpenShift, and then you can run some of the things like you saw I did here. And if you wanted this actual demo code, I could get you that too if you wanted it. But what kind of questions do you have? Yes, sir.
Do you see enterprises running this without a physical DMZ? Do you see anyone just putting this directly onto the internet? Or?
So putting like this entire stack on the internet? I can't think of, I have seen one. Have you seen any?
I've not, but I'm more at the infrastructure level. I don't deal with the middleware folks enough to have seen the actual applications. OpenStack, yeah, but
Will the OpenStack get
But
without
just-
a physical DMZ?
yeah, just OpenStack.
I know
I'm
I know
not
people are
working with
starting to
anybody
work on that,
there.
but I'm not sure if there's one already in production today and that might be my fault for not keeping up with what's going on there. Yeah. What other questions do you guys have? Okay, I'll ask you guys a question. How many people here are software developers who work at that top layer of the stack? You build PHP applications, Python applications, Ruby, Node, Java. Okay, so about half of you guys are more on the programming side. Did you see any advantages here for you as a programmer for actually launching and controlling your components, right? Whether they be services to do integration or BPMS processes or just a web app. We could showed you that too, but that's too easy, right? We could have started that out there too. Does that sound cool for what that is?
I haven't seen a WordPress launch before.
I used to do WordPress demos a year ago, and people are like, wow. I'm like, okay, it's not that exciting. And for people who are not at the programming level, if you're on the lower layers of the stack, you're more focused on the operational side or administrative side, things like that. Did you see any value here as well, that things that might make your lives easier in the future, we hope? Yeah? Back in the back, were you Kevin?
Oh, yeah.
The guy who's sending out our tweets? Okay. So any questions at all, though?
So
Yes, sir.
You showed me like Salesforce in the container. Like, what did you do that?
Well, Salesforce in this case is truly external to our containers, and we just are connecting out to it. We are just, what's running in a container here is specifically our component that says, grab the tweet off our queue, go to Salesforce, find the matching Salesforce record, and then come back and run the BPM process. So Salesforce in this case is not running in our little container. But we wanted to show integration from on-premise hardware out to the cloud-based SaaS, in this case software as a service, back to on-premise. Because that's a common use case, right? You need to be able to integrate not just a couple different services on your local network. You're going to want to be able to integrate across multiple cloud-hosted services at some point in the future, if not now. And this was just an example where we wanted to illustrate that point. You know, not everyone uses Salesforce yet. I appreciate that, but you might think of another cloud service that you eventually want to integrate your on-premise middleware, technology, software, PHP stack, Node.js stack, COBOL app to something else. That was kind of the basic idea.
So what is your main strength relative to, you know, deploying your web apps on AWS or Rackspace or what have you? What is that the customization aspect of it?
Okay, so the main strength of what we showed you here versus, let's say, Amazon Web Services or Rackspace.
Right.
So this is primarily for those organizations. You could actually deploy all this on AWS, by the way. But this is for organizations who want to have their own cloud, if you will, right? So think of that as the private cloud. It's in their data center, behind their four walls or firewall, if you will. But also the concept of the hybrid cloud, where they, if they need to, can spill over to, let's say, a Rackspace or AWS and take advantage of services and capability there. Do you want to answer that also?
Or maybe one of those providers has just made you really mad and you want to run it on your own hardware. No, I think Burr covered it. You know, private versus public, having control over your own hardware. You know, there's nothing wrong with using Rackspace or AWS, and what we've shown you, OpenStack could be replaced by those. You know, really the OpenShift Online could be used just as Burr showed you, where he started to launch those gears there. You know, the underlying infrastructure behind that, you could rely on OpenShift Online to run that fuse gear instead of having your infrastructure underneath there. It's all of these different layers are kind of give and take that you can mix and match to different clouds, different services, different providers as you see necessary to fit your particular need for what you're trying to accomplish. Anyone else?
We have time for one or two more questions if you guys have one. Yes, sir. The what? Oh, the YAML files? Camel files, yes, but is that what you mean, camel? But YAML, no, I don't have a YAML editor that I can think of. You know one?
Specific to Heat, to do orchestration?
Right, because my team has been working to create e-templates that we pass in, and we visually create those and send those to the Heat. And you can actually use Heat outside of OpenStack as well, and that's what we've done initially, but we will have Heat integrated with OpenStack to provision the VMs, install the apps, do everything.
There was kind of a proof of concept one written at one point, actually in the kind of pre-alpha version of what has become the Heat web UI. There was a visual editor that was kind of started, and everyone decided it was too much to bite off before we actually got Heat into the web interface for OpenStack. So the idea is not a far-fetched idea. I think it's something that just hasn't come to fruition in general, Heat's a very young project compared to most of OpenStack at large. So contributions accepted? Is that a good answer? I'm sorry?
IBM has actually built a product. They actually lay it over top of Heat and extend it.
Yeah. There's a few, I think there are a few visual orchestration pieces like that, but something that comes out of the box with Heat, I don't think there's one that exists.
And all I did here was pull up the camel editor we have. This is the layer I live at, right? So if you want to design a route visually, there's primarily an Eclipse editor people use, but there's even a web editor we've been working on. And so you can kind of, you know, if you want to change your camel route, right, your integration layer, but that has nothing to do with YAML. All right, well, thank you guys very much for your time. We're hit the top of the hour. Dan and I'll be here for a while longer. If you have any other questions, I'd love to discuss your use case and what you're working on.
Thanks,